Okay, so dear students, we have done this all. Let's start studying the next topics. This is very important, not only for the examination point of view. I'm again saying this chapter will create your base actually for studying proper kinematics. Okay, means in the 11th and 12th standard we will be going to study the motions in great detail, and there will be different types of motion we'll be going to study. So this chapter will create your base for that one also. So let's do some questions. First of all, you need to do one thing here is that, dear student, that whenever we are solving the questions using the three equations of motions, okay, for examples, if I'm having here if I'm having three equations of motion, one is v is equals to u plus at, v is equals to u plus at. In the second equation we have v square is equals to u square plus, the second equation of motion, the first equation of motion is v is equals to u plus at. The second equation is v square, sorry, s is equals to ut plus half at square, and the third equation is v square is equals to u square plus 2as. Okay, we have the four physical quantities mainly, five physical quantities mainly. One is the v, that is the initial final velocity, final velocity. The second one is u, that is initial velocity, initial velocity. The third one is that is this s, that is displacement, displacement. The fourth one is acceleration, acceleration. The fifth one is time, is time. Okay, dear students, one thing you need to notice here that acceleration is common in all. You find here that acceleration is also in this one, acceleration is also in this equation, and acceleration is also all in this equation. So if we are going to calculate those motions that are accelerated motions, okay, that are not going to have uniform, that are not going to have zero accelerations. Okay, I'm talking about the accelerated motion. So in the accelerated motion, generally these equations are very suitable. Otherwise, means these equations work for the accelerated motions, accelerated motions. Okay, if in simple, if the motion is not accelerated, for the motion which is not accelerated, which is not accelerated, okay, then in such type of equations, so for solving such type of numerical, we have a simple formula, that is speed is equals to distance upon time, distance upon time. And this is a simple formula. Here there is no acceleration, there is only distance or displacement, is time and speed. No initial velocity, no final velocity, because the speed will be constant, because if there is no accelerated motion, there will be no change in the speed. So if I'm saying that if the motion is not accelerated motions, or with zero accelerated motions, if the speed is not changing with time, then this formula is going to work. Okay, okay. This or if the motion is escalated, means if the speed is changing with time, so this formula is not going to work. We will use these formula for calculating the accelerated motion. So all of these equations is going to have acceleration as common, and you need to keep in mind here that in any one of the equation, means if in this equation displacement is lacking, means we don't have the displacement in this equations. In this equations, what is lacking? It a final velocity is lacking. We don't have the v. Okay, and in the similar way, in this equations we have that is a formula in this, and we don't have the time. So they in this the if in this the displacement is lacking, in this the final velocity is lacking, in this the time is lacking. Otherwise there is one physical quantity lacking in all. So how can we apply the formula during the while solving the numerical problems? So let's solve some NCERT problems. Okay, that's very important from your for your examination point of view. Okay, so let's solve those one, and then we shall be going to discuss in detail about the other types of motion. So wait a minute, let me find out the questions, then we shall be going to discuss that one. If you have any doubt regarding, and if you have any questions related to this topic or related to motion chapter, then you can ask your questions also. That will be I will be very thankful to you, that if you ask some questions, it will indicate that you are studying at home. So let me give you some beautiful questions that will help you for your examination. So let me find out that. Please wait a minute. Okay, so I'm sharing the screen right now. Okay, so this is the uh, is my screen is visible to you all? So let me share. Let me solve these questions. Let us solve. Okay, so these are very simple questions. Let's talk about this one. Let's go through this question. Okay, here we have a bus. A bus decreases its speed from 80 kilometer per hour to 60 kilometer per hour in 5 seconds. Find the acceleration of the bus. Okay, find the acceleration of the bus. If I need to copy this question, let me copy this one, and then we shall solve these questions here. Okay, so let's solve this question here. Uh, yes, Miradullah. How can we solve such type of question? Do you have any idea? Do you have any idea? Hey, is I'm audible to you all?
Yes, sir.
Then why are you not replying? I'm asking you something. So here is a question. How can you solve this question? How will you solve this question?
So there is also final velocity and initial velocity is given.
We have the initial and final velocity given. So first of all, we need to discuss. First of all, it is to write the biography of the questions. Okay. So it is being given that the speed of the decreases. The speed is decreasing here, and you need that the initial velocity is 80 kilometer per hour. So you need to write here 80 kilometer per hour. Okay, 80 kilometer per hour, and the final velocity is 60 kilometer per hour. Okay, and the time is 5 seconds, and what is being asked, acceleration is being asked to you. Okay, so you need to know that which one is missing here in this question. What is missing? You need the displacement is missing. Displacement is missing. Okay, this is not being given to you. The displacement is missing here. Okay, you have also written here that what is being asked in the question, the acceleration is being asked, so you have written here A. Okay, but what is missing? Displacement. There are 5 quantities that I have discussed in the previous slides. I have discussed that there are the five quantities, 5 physical quantities. Okay, so displacement is missing, so you know that V is equals to U plus AT. This is the first equation. Second equation is going to have UT plus S is equals to UT plus half AT square, and the third equation is V square is equals to U square plus 2AS. So the physical quantity that is missing, that is S. So S is in this one and S is in this one also. So we have to use this equation only. Means we can solve this by using this equations only. Okay, simple. That is V is equals to U plus AT, because S is missing. So S must be there in this equation and in this equation. So we need not to we only use that equation in which the S is not there. So S is not there in this equation. So we will solve this by using these equations. Okay. First of all, you need to keep in mind here that whenever we are just solving such type of equations, you need to keep in mind here that the speed is given here in kilometer per hour, and the time is given in seconds. Okay, so there is one step that first you need to change this one into meter per second by multiplying it 5 by 18, and similarly you have to change this one also and by multiplying it by 5 by 18. So this is the one way. Okay, another way to change it is we need to calculate the acceleration. So we know that acceleration is equals to V minus U by T. This can be drawn from this equation. Okay, so A is equals to V minus U by T. Okay, so you know that, simply that if I subtract the 80 kilometer per hour minus 60 kilometer per hour, 80 kilometer per hour is being subtracted from the from 80 kilometer per hour is subtracted from, sorry, 60 kilometer per hour is subtracted from 80 kilometer per hour. The resultant will be 20, and that will be also in kilometer per hour. So it is better to first you subtract it, and whatever the answer comes, then you convert this one into the meter per second. That will be more easier rather than converting first 80 into 5 by 18, then minus 60 into 5 by 18. Or you can do this one by also by taking the 5 by 18 as common, and then you can 80 minus 60, and then you can the result will be 20 into 5 by 18. Okay, you can do like this way, or you can calculate that. It will be simple that A is equals to 80 minus 60. Whatever the answer comes in the it will be in the kilometer per hour, because when kilometer per hour is being subtracted from kilometer per hour, then it means that the answer will be in kilometer per hour, and the here the speed will be in kilometer per hour, and you need to convert that speed into meter per second. Why? Because the time is given in seconds. The time is given in second, not in hours. Here the speed is in hour, the time is in hour. So but in questions it is being given in seconds. So here we have to write here 5 seconds, and here we have to multiply it by 5 by 18. Okay, so simply what you can do here is you have to write here A is equals to 20 into 5 by 18, 5 by 18 upon 5. Okay, now you know that this is 20 into 5 by 18. Okay, you are converting the kilometer per hour into meter per second. That is 5 by 18. So you have to multiply. So this will be 100. 5 to the or you can write it. You can divide it like this way. You can divide it 9, and you can get 10. So you will get here 10 into 5, you will get 50. So you will get here 50, okay, upon 9 is being divided by 5. Is dividing means this is the whole numerator, and this is whole being divided by 5. So you can write here 50 upon 9, and this will be changed into multiplication sign. You can write it 1 by 5. Now you cut it, you will get 10. So that will be 10 by 9 meter per second. Okay, square. So acceleration is approximately, you will get the acceleration will be uh, actually you need to keep in mind here that the velocity should be we have done some mistake here, and that is we have the initial velocity as 80, not the final velocity. So the resultant answer will be minus of here and plus of here. Okay, why I'm saying this one? Because the initial velocity, let me do the corrections. Okay, let me do the corrections. So here you have to write that will be 60 minus 80, and that will be minus of 20, and this will be minus of 50 by 9, and the answer will be in acceleration will be minus of 10 by 9, that will be 1.1 meter per second square. Meter per second square, minus of 1.1 meter per second square. Got it? Or still having some doubt?
No doubt, sir.
No doubt. Please copy this question. Copy this one.
Done, sir.
Hamna, you have done? Have you done, beta? Have you done? Hamna?
Yes, sir, done.
Okay. Okay. So let's move towards the next question. Okay, let's move towards the next question. Here is our next question. So let's move towards it. Okay. So a train starting from the rest of the railway station is moving with a uniform acceleration with 10 minutes. Find its acceleration. So you need to do this question in homework. That's very easy. Okay. The train starting from the station means starting from the station. It means its its initial velocity is 0, and here moving with a uniform accelerations and attain a speed of 40 kilometer per hour in 10 minutes. Find its accelerations. You need to find out its acceleration, and that's very will be similar to that above one. So that's is easy. So let's move towards the next question. Okay, let's move towards the next question. What is the nature of distance time graph for the uniform and non-uniform motion? So that's you know very well the nature of the distance time graph for uniform motion is a straight line. Okay, and for non-uniform motion it is a curved line. Okay, and what can you say about the motion of the object whose distance time graph is straight line parallel to the time axis? In which distance time graph that it is parallel to the time axis means object is stationary, object is not moving. So in this question we simply can say that the object is not moving, the object is not moving. Okay, clear or having some doubt? In question number 2 you can simply say that the object is not moving because its graph is parallel to time axis. Okay, got it?
Yes, sir.
What can you say about the motion of the object if the speed what can you say about the motion of the object if its speed time graph is a straight line parallel to time axis? Straight line parallel to time axis. So what does it means? I have taught you these graphs in very much detail, that if in speed time graph, how many tell me if this in if speed time graph, if in speed time graph the velocity the graph is straight line means the line is straight parallel to the time axis, then what does it indicate? What does this indicate? Parallel to the time axis. It is parallel to the time axis. Tell me. So if you have in a speed
So
time graph,
uniform motion.
yeah, it will be considered as uniform motion. Okay, we have done this it is in detail. So if you don't have this, so you can copy this one, check in your copy. Okay, so what is the quantity which is measured by the area occupied below velocity time graph? Tell me. In the velocity time graph, what is that physical quantity that can be calculated with the area below the time graph? Velocity time graph means if you have a velocity time graph, for example, let me explain you here. Okay, uh, for example, in this graph you see that we have velocity time graph. Okay, so let's we have the velocity time graph. Velocity time graph. First, in the first question, I'm scaling this one. This one is parallel to this time axis. This means that this is the velocity time graph. Velocity time graph. Velocity time graph. It means the object is moving with constant velocity. Whatever the speed will be here, that is 50 meter per second. It means the object is moving with a constant velocity of 50 meter per second. Okay, and in case if yes, Muradullah, tell me, do I want to say something?
So if this is same situation is in so distance time graph, sir, it is considered as the object is not moving. No?
Yeah. If it is a distance time graph, it means if it is a distance time graph, and whatever the distance is, let's suppose it is 20 kilometer, 20 kilometer. Okay, you have traveled somewhere, and you take 2 hours to travel this 20 kilometer, or some hours to take to travel this 20 kilometer, and you park your car. The graph will be like this. The car is in parking, and the graph it will be considered as means the object is not moving. Object is not moving here. Okay, and it means the velocity is constant. Velocity is constant. Object is, or we can say uniform motion. Uniform motion. Okay, and if you have a graph like this way, like this, and gives us area under VT graph. Area under VT graph.
Sir, displacement.
Yes, it will gives you the displacement. How can we calculate this? We know that area if I'm just calculating, for example, just keep in mind this is a trick that how can you calculate, how can you remember that what the area is going to give us. For example, you have a square or a rectangle, you know, if it's breadth and it is length, so what you need to do if you need to calculate the area, you simply multiply L into B. This is a simple easiest way to calculate. In the similar way, if you need to calculate the area of this one, you need to multiply the velocity into time. Okay, so velocity into time gives you what? Which physical quantity velocity into time will gives you? Okay, if you need to calculate the area of this triangle, you need to multiply it half into velocity into time. Means you have to, whatever the value of this is the numerical word. Okay, let it be. It might be half into v half, or it might be, if it is a square form like this one, it may be v into t only. If the area is like this, it may be v into t only. Okay, so depending on the case and the graph, multiply half into velocity into time. You will take this one velocity and this will take the as the time. So in the similar way, when you are multiplying velocity into time, what you will get? You will get the displacement. You know very well that displacement is equals to displacement is equals to velocity into time sorry, displacement is equals to velocity into time, or you can say that velocity is equals to displacement upon time. Displacement upon time. Okay, in displacement, okay, now it's okay. I think you understood this one. Got it, or having some doubt?
No doubt, sir.
No doubt. Okay, let's move further. Let's discuss the next question here. Okay, we are having we have solved this one also. Okay, let's do this question. Let's do this question. 8.5. A train starting from rest. Okay, a train starting from rest, attain, assuming this one velocity. Copy. So let's start this, doing this question. Okay. So let's start. Okay, here's a question. A train starting from rest attain a velocity of 72 km per hour. Okay, in 5 minutes. A train is starting from rest. Whenever it is saying from the rest, what does it means? What does it indicates? Hamna, what does it is indicate? What it is indicating? What is it? What is it indicating when an object is said to be rest?
So the initial position is 0.
Yes, initial velocity is 0. Hamna is Hamna. Why are you not responding? Hamna, are you there in the
Yes, sir.
class? Beta, I'm asking you. Are you there in the class?
Yes, sir.
Okay. So if I'm saying that, do not let your mic off. Okay, so that you can instantly answer me. So a train starting from rest attains a velocity of 72 km per hour. What does it mean? Starting from rest means
Initial velocity is 0.
initial velocity is 0 meter per second. Okay. Okay. Here it is being given in kilometer per hour. So we can say it is 0 km per hour. Okay. And in 5 minutes, the time is given that the time is 5 minutes. Okay. And assuming the acceleration is uniform. If the acceleration is uniform, find the acceleration. First, you need to find out the acceleration. Okay. And second, the distance traveled by the train for attaining this velocity, means how much distance. Here the final velocity is given, that is 72 km per hour. 72 km per hour in 5 minutes, means this speed is attained by the train in 72 km per hour in 5 minutes. Okay, when it is traveling with the uniform accelerations. So we need to calculate first the acceleration, and secondly we need to calculate, what we need to calculate is, we need to calculate the distance that the train traveled in 5 minutes to acquire this speed. So we need to calculate the distance also. Okay, displacement also. Okay, so first of all, which equations we will use in this to solve this or to calculate this A? Which equation is suitable?
So V is equal to U plus 80.
Yeah, because there is no S, so in other two equation there is S is there, so we need to calculate the okay, so we need to calculate the acceleration by using the first equation of motion, and that is simple. We have this direct formula, A is equals to V minus U by T. Okay, but here the time is in minutes and speed in kilometer per hour. So first of all, we need to convert everything in meter per second, and time is also in seconds. That is very important, that the proper convergence of unit must be there. Everything must be in standard SI units. That is, the distance has a standard unit of converted into meter per second. How much what will be the value? Tell me. What will be the value when the velocity is converted into when final velocity is 72 km per hour is equals to how many meter per second? Tell me. Tell me, beta. How much it will be in meter per second?
So 20.
Yes,
20
very
meter
good.
per second.
20. Yeah, this will be 20 meter per second. How we know this one? How we know this one? This is 72 into 5 by 18. You multiply this one. 18 ones are 18 fours are, so 4 into 5 you will get 20 meter per second. Okay, so here we can say that this is equal to 20 meter per second, and similarly time, 5 minutes will be equal to how many seconds? 5 minutes is equals to how many seconds? Tell me. 5 minutes is equals to how many seconds?
So 300 seconds.
Yes, it will be 300 seconds. 300 seconds. Okay, so you need to calculate it as that V is equals to U plus AT, or you can calculate A is equals to V minus U by T. So A we need to calculate, V we have the value, that is the 20 meter per second. Find initial velocity 0 upon 300. So acceleration will be 20 upon 300. 0 0 cancel, you will get 1 by 15 meter per second square. Okay, or you can divide it. You can also calculate in decimals also. Okay, let it be in fractions because you need to calculate some other values also. Okay, so our here we see that our acceleration is 1 upon 15 meter per second. Okay, 1 upon 15 meter per second square, sorry. So now we have the A, we have the value of A. Okay, A, and that we have calculated here. Now that is known to us, and that is 1 by 15 meter per second square. Now you need to calculate the S. Which equation will you use? Which equation will you use? So you can use any one of the equations in the remaining two. Why? Because
The
we have,
second and third, so both we can use.
yeah, second and third both we can use. So it is better to use second equation, because second equations is directly will give you S, because it is it is for calculation that S is equals to ut. Moreover, u is initial velocity is 0, so this product will be 0. So it is easier and more convenient that we use if we use S is equals to ut plus half at square. Okay, so we can calculate S is equals to 0 into t. Whatever the time, it will be 0. So plus half into A. Acceleration we have calculated 1 by 15 into T is 300 square. Okay, so S will be equals to this will be 0 plus half into 15, 1 by 15 into 300 into 300 into 300. Okay, so this, the product of these two will be 30, 15 to the 30, and this 30 when divide 300 you will get 10 here. Okay, so you will get 3000. S is equals to 3000 meter. This means we can say that S is equals to 3 kilometers. Okay, got it, or still having some doubt?
No doubt, sir.
No doubt. Please copy this one. Hamna, are you getting the questions or still having some doubt? Do you understood?
Yes, sir.
Okay. Okay, beta. So it is easier for you that if you do and solve these questions like this way.
Sir, done.
Hamna, have you done, beta?
Yes, sir.
Okay. Let's move further. Let's move to the next questions. And there we have 3 kilometer is the answer. Okay, and this is the answer. Okay, is there any questions? Okay, it is being also asked that calculate the distance. Acha, we have done this one. Okay, the distance traveled by the train for attaining this velocity. So this was it. Okay, this is the question for this one. Car accelerate from say in 5 seconds. Calculate the accelerations time covered with this one. You can easily calculate this one. So do this. Okay, solve this question, please. I'm going to give you solve this question. This is very easy. Let me check whether you are able to do this one or not. This is very easy. So let me check. Okay. What is this? A car accelerates uniformly. This is some mistake has been done. Okay. Wait a minute. So solve this question. Calculate this one. Please turn on your camera. Let me check whether you are doing or not. Please turn on your camera. Muradullah and Hamna, please turn on your camera. Let me check whether you are doing or not. Hamna, have you calculated? Hamna.
So acceleration is equal to 1 meter per second square.
1 meter per second. Acceleration is 1 meter per second square. Okay. So
Yes.
okay, let's check. First of all, you need to do what? You need to calculate the acceleration. You have a car accelerate uniformly. Initial and final velocity is being given to you, and A is also being given to you. So you have been given that U is equals to 18 kilometer per hour, and final velocity is 36 kilometer per hour. And time is being given to you, that is 5 seconds. And A you need to calculate. So A is equals to V minus U by T. So V minus U is V is given and U is given kilometer per hour. So first you need to do is you need to minus 36 minus 18 into 5 by 18. Whatever the resultant comes, it will be in kilometer per hour. And this kilometer per hour can be converted into meter per second by multiplying it by 5 by 18. Okay. So what we need to do is whatever the answer comes, that will be, if I subtract kilometer per hour from kilometer per hour, then answer will be in kilometer per hour. Okay. If you have 5 kg apples and you gave 2 kg to anyone, yeah, to someone, okay, to your friend or okay. So then that is, if you give 2 kg, then the answer remaining will be in kg also. It will not converted into grams or milligrams. The answer will be in kg. In the similar way, if you have 36 kilometer per hour and then you subtracted 18 kilometer per hour, then the answer will be in the kilometer per hour. So for the answer, whatever the answer come by subtracting, we need to convert that kilometer per hour into meter per second, and it can be easily converted by 5, multiplying by 5 by 18. And here you need, the time is already given in seconds, so no need to convert it. So here it is 18 into 5 by 18 upon 5. So these 18 will cancel out. You will get here 5 upon 5 and that will be equal to 1 meter per second square. Okay, got it? Got it?
Yes, sir.
Very good. And then the distance covered by the car in time. You need to calculate the distance covered by car in time. So S is equals to here, A is being given to you, that is A meter per second square.
So it says 37 meter per second. So sorry,
Oh.
meter. So sorry, meter.
37 meter.
So
Okay,
37.5 meter.
okay, let me check. That will be 8. You can calculate it by using any one. Okay, so S is equals to UT plus half AT square. So S is equals to UT. U is initial is 18 into time is 5 plus
So
half.
we can also create. So we can also calculate this.
By using the third equation also.
Yes, sir.
1 into T is being given to you, that is 5 into 5. That will be 25, or you can write it 5 into 5. So this will be 90 plus half into 25. Okay, 90 into half into 25. So when you cut it, what we have done? Oh, sorry, that's one. I have committed a single mistake here, that I have not converted here the initial velocity into meter per second. So I have to convert first initial velocity into meter per second, and that can be easily converted by 18 into 5 by 18. So you can convert it, you will get 5 meter per second. So here this is 5 meter per second, and this one is 10 meter per second. Okay, if we convert it. Okay, so here is a silly mistake. That is, you need to keep it, that is 5. 5 into 5, that is 25. Okay, so you will get here 25, and then you cut it, you will get 12.5. So plus 12.5, then you add, when you add, you will get 37.5 meter. Got it? Hamna, please do this one. Copy this one. Have you done? Hamna? Hamna is not applying today. क्या हुआ Hamna को? Hamna, are you there in the class?
Yes, sir.
Why are you not
Done.
replying? Done. Okay. Okay, you mailed me, Radhula. Okay, I will check it. And Hamna has not mailed me. Everyone has mailed. Okay, let's move further towards the next question. Let's move further. Let's have some interesting question now. Find the speed acquired, and this is direct formula. A train is traveling with a speed of 90 km. Brake is applied to produce acceleration of 0.5 square. How far the train will go before it stops? Stone is thrown vertically apart. Okay, let's do this question. Okay, let's do this question. Okay, we have this question. A stone is thrown vertically upward in upward direction with a velocity of 5 meter per second. What is being given to us? Stone is thrown vertically upward, Okay, so there is a stone and it has been thrown vertically upward and with the initial velocity of 5 meter per second. Here we have the initial velocity is 5 meter per second. Okay, if the acceleration of the stone during the motion is 10 meter, we have the acceleration, and you know very well that when the objects move upward, you know very well that when the object move upward, its velocity continuously decreases and the highest point it becomes zero. At the highest point it becomes zero. So you need to keep in mind here that whenever the velocity is constantly decreasing, in that case we need to take the acceleration in negative directions. Whenever it is being applied that the accelerations means it is being given that an object is thrown upward, then we need to take the acceleration as a negative because the speed will continuously decrease. Whenever the brake is applied, then we need to keep in mind that we need to take the acceleration in the negative. So whenever the speed is constantly decreasing, we consider the acceleration is in negative. Okay, so a will be in 10 meter per second square will be in negative. In the downward direction, uh, uh, if this acceleration of the stone during the motion is in the downward, it is being given that it is in the downward direction. Downward direction means, and the object is moving in the upward direction, so acceleration will be taken as negative. Okay, what will be the height attained by the stone, and how much time will it take to reach there, and how much time will it take to reach there? Means at the highest point, what will be the we can say that height it will acquire, and how much time will it take to reach that point, and how much time will it take to reach that point. So we need to calculate the time. So what will be its final velocity? Let me know what will be its final velocity. You need to calculate the height is also equals to displacement. You need to calculate, and what will be its final velocity? Tell me what will be its final velocity at the highest point. What will be its final velocity? Tell me, do you have any idea what will be its final velocity at the highest point?
So 0.
Yes, at the highest point, its velocity will become 0 and it will start coming back. So at the highest point, the velocity will become 0, means its final velocity will be considered as 0. Okay. So first of all, you need to calculate the time. You need to calculate the, or you need displacement will be calculated later. First, you need to calculate the time. How much time will it take to reach the highest point? Okay. So how much time will it take to reach the highest point? How much time will it take? So you have A, you have V, you have U, and you have T. So using this, and this, which equation will you use? Which equation will you use?
So V is equal to U plus AT.
Yes, we will use V is equals to U plus AT. Here V is final velocity is 0. Initial velocity is 5 meter per second. And acceleration is minus of 10. And time you need to calculate. Calculate the time.
So 5 seconds.
Yes, 5 seconds. No, it will goes to that side and this will become minus of 5. Okay, and this will be minus of 10 into t. Okay, so this minus will get cancelled out and you will write here what you will write here. You will write here 5 upon 10 is equals to t, so it will be 0.5 seconds. Okay, t is half second, or you can write it 0.5 second. Okay, the time is 0.5 seconds. So the object will move at its highest point in just 0.5 seconds. Okay, if you throw an object with a speed of 0.5 seconds, then its velocity will become 0 in just 0.5 seconds. So this is the time period. Now you need to calculate the s. S means the maximum height will it reach. So what will be the maximum height will it reach? Tell me. Calculate it. One thing you need to keep in mind that you need to know that time can never be negative. Time can never be negative. If your value, if you when you are calculating something, and if you are getting the time as negative, then you consider yourself that you are committing or some mistake. Okay, you are committing some mistake, that's why your answer is in negative. Okay, so you need to keep in mind this one. What will be the displacement? What will be the maximum height it covers? Tell me, Maridullah and Hamna.
So I'm doing it.
Instead of using 0.5 second, use if you are using second equation of motion, use 1/2. Done. So you have to calculate here S is equals to ut plus half at square. S is equals to your initial velocity is 5, time is half plus half into acceleration you have calculated, that is -10 into t square, means half into half. Okay, so this will be S is equals to 5/2 plus this 10 will get cancelled out here by
So minus 7.5.
how much it will be?
Minus
Minus 5
So
by
minus 7.5.
minus 5/4. Okay, so you have to calculate here, you have to multiply it by 2 and you have to multiply it by 2. Okay, your answer is minus
So minus 7.5.
minus 7.5.
So 5. Yes, sir.
Let me check. It should not be negative. It should not be negative. Let me check. This should be you will calculate, you will get here 10 upon 4 minus 5/4. So that will be 4 upon 5. That will be 1 point some meters. 1.25 meters. 1.25 meters. Where you are committing mistakes? Maridullah, show me your copy. Show me your copy, please. Show me your copy. We are committing mistake. Is it possible that you can show me your copy?
So I'm taking class on laptop.
Or you are taking the class on laptop? Okay. So check it. Have you used this equation? S is equals to ut, or have you used this third equation of motion? Which equation you have used?
So S is equal to ut plus half at square.
So where you have committed, this is the initial velocity is 5. We have done. T is we have calculated is half, and then at square. So you have to write here half into a. What is a? A is -10. You have to write here -10. Have you written -10 or +10?
So minus 10.
Okay, -10. Then again t square. Then t is half, again half into half. You will get So this will be, when you multiply 5 into 2, you will get 5 by 2 here. Okay, 5 by 2. And
Sir,
when you
I
will,
solve the minus.
yeah,
So in last, so I solve the minus 10.
you solve the minus 10, na? So
How
this
fine
one
So in the last. So in the last.
means you got your mistake that you have committed.
Yes,
First you,
sir. Yes, sir.
okay, okay. So copy it, please copy it. Hamna, have you copied? Hamna?
Done, sir.
Hamna, have you done? आज हमना का इंटरनेट प्रॉब्लम है क्या कुछ?
Yes, sir. Done.
Do you understand? You are not attentive today. Why you're not instantly replying what I'm asking to you? Do you have any problem? Hamna, do you have any problem today?
No, sir.
Then why are you not instantly replying? I'm asking something. Okay, so this is all today. That's all for today. And if you need to copy, if you need any notes regarding to any chapter, so you can mail me, please. Last topic is the circular motion that we will do in the next class, and then after that one, this chapter will be finished, and we shall be solving the next problems. So here we have some questions also, and that's very easy. Okay, let's solve this one. A ball is jointly dropped from the height of 20 meters. If its velocity increases uniformly with the speed of it now, what is the velocity when it strike the ground? It is same. Here the acceleration will be taken as positive because the ball is being dropped. And when the ball is being dropped, you know that if we throw a ball, if we drop a ball, then its speed will constantly increases. And here the initial velocity will be considered as zero. Why? Because the initial velocity is zero, because when we are dropping something, that initial velocity is zero, and we need to calculate its final velocity just before touching the ground. So that's will be very easy. You can calculate it by using v is equals to u plus at formula. Okay. So after a times, after what time will it strike? So time is not being given to you. So how will you solve this question? Let's solve this one. Let's solve this question. That's the last question. Let's solve this one. Then the class will be over. Okay. So let's solve this one also. So let's solve. So here it is being given that that the initial velocity of will be considered as zero. Why? Because the ball is being dropped. Acceleration will be considered as positive 10 meter per second square because the speed is constantly increasing. When we drop a ball, then the speed will constantly increase. Okay. And here you need to notice that final velocity we need to calculate, and time we don't know actually. Okay. uh, Here the ball is gently dropped. If the velocity increases in inflation, what is the velocity will it touch the ground? So here we don't have the final velocity. After what time will it strike the ground? We don't have the striking the grounds. We don't have the time period also. So in such type of questions, we don't have the we have the two unknown quantities. We don't know the velocity, final velocity. We don't know the time period. We know only our accelerations and initial velocity, that is zero. And the here s is being given to you, that is displacement, that is 20 meter it is being given to you. So here the displacement is being given to you. Here the velocity it is being asked, okay, and here acceleration is being given, here the final velocity. What is not given to you, that is, you can say that time is not given, okay. So let this, we exclude this quantity, so we, in which equation do not have time. So we know that as v is equals to u square plus 2as do not have time. So we can easily solve this equation by using this formula, and that will be equals to v square. It means v square you need to calculate actually is equals to u square is 0 square plus 2 into a is 10 and s is 20. So that will be equivalent to 0 plus 400. 400 is equals to v square. So v square is equals to, you can write it, 400 is the square of 20. So we can write here v square, square will cancel out, v is equals to 20 meter per second. So when the grounds, when the ball touches the ground, its striking velocity will be 20 meter per second, okay. And we need to calculate the time here. Time you can calculate by using any one of the equation. We have the v is equals to u plus at, or we can calculate it, time is equals to, by using we can write v minus u by a. So what is initial velocity? Final velocity is 20, initial velocity is 0, and acceleration is 10. So that will be 2 seconds. 10 by 20 by 10, that will be 2, that will be 22 seconds, okay. So 2 seconds will be the time. So copy this one also, and that's all for today. So I think you understood, or still having some doubt regarding to these questions. Have you understood how we calculate
Yes.
this one?
Yes, sir.
Okay, please note down this one. Please note down. Done.
Yes, sir.